Okay, one last problem on geometric series, and then we'll work on something else. Not too much else. This is about done, but I don't know why I said that. Okay, one more. So we're gonna find the values of x so that the sum n equals 0 to infinity, negative 4 to the n, x minus 5 to the n, converges, and find the sum. Okay? So, the sum n goes from 0 to infinity, negative 4 to the n, x minus 5 to the n. Well, first thing, this is equal to the sum n equals 0 to infinity, r of x to the n, where r of x equals negative 4 times x minus 5. Okay? Right? That makes sense? All right, so now, in order for this to converge, this thing needs to be less than, or absolute value less than or equal to 0. Did I say 0? I meant 1. And not less than or equal to, but less than. Man, sometimes I don't know what I'm saying sometimes. Okay, so negative 4 x minus 5 absolute value should be less than 1, right? Remember our ratio in the geometric series should be less than 1. So this is our condition. So let me write this as negative 1 less than, I don't need the negative here on the negative 4. Like so. Dividing everything by 4. Adding 5 to everything. So what do we get? We get 5 minus 1/4 is 19 over 4 to 21 over 4. Okay, this is called an interval of convergence. This 1/4 that we found, we can call that a radius of convergence. Move it over there. And what that means is that says that we have this interval around 5. And that interval has a radius of 1/4. So I know it's weird because we're doing it in one dimension, but really, this is an idea that extends to multiple dimensions, including 2. So the word radius here does make perfect sense. Okay? Now, if we're in our interval of convergence, Okay, if we are in our interval of convergence, then our summation, we write it down. Then remember that's going to equal, our first term is 1 over 1 minus r of x. So that's going to be 1 over 1 plus 4 times x minus 5 equals what? 1 over, why would I write that? 4x minus 19. Okay. Now, I'm gonna go a little bit beyond what we do in Calc 2, and by a little bit I mean a lot beyond. But not very far, not very long. Okay, so this is true if x is there, right? Okay. Now remember I told you about that sum 1 plus 2 plus 3 equals negative 1/12? What I'm about to talk to you about is related to that. What they do, okay, is they say, you know what, we have this equality true here. And then they try to push it. They try to push it outside that region. Okay? That's something called analytic continuation. And then when they want to add up 1 plus 2 plus 3 plus 4, that is an analytic continuation of some other series. Okay, so the sum itself doesn't have meaning except for through this process that they call analytic continuation. Okay, so we could extend this beyond this interval, but that is just that's a higher level of mathematics. It's something I haven't even read that much about. Okay, I should say I even, as if I'm the god of math. No. It's something I have not read that much about, but there are some people at USF that have. Okay, all right. One more video, and then I will call it a day.